Hello class, this is Mrs. Ayodeji with today's video on 10.1 composition of functions. As you're watching the video, please make sure to write down important vocabulary, formulas, equations, and examples. Feel free to pause, rewind, and repeat as often as you need if you don't understand something. And remember to identify what questions you still have and submit them via the online WISC after completing your watching of the video. All right, let's begin. Today we're talking about composition of functions. In this case, we're not looking at particular functions. We're just dealing with just general functions, any function, no matter what type. And the composition of functions looks something like this. Suppose I have a function that takes apples and turns it into lemons. And then I have a function that takes lemons and turns it into oranges. So if I put the functions together and I start with apples and I output the lemons and into the other function and put those lemons and out comes apples, then I have what's called a composition of two functions. And I can start with apples and I end up with oranges, even though there is no one function that takes in apples and produces oranges. We combine two functions that do what we needed to do so that we can get the desired result. Your book says that the definition of a function that looks of this format is said to be a composition of f with g, and the function of f composed g is defined by using the output of the function g, in this case lemons are the outputs of the apples, and use those outputs as inputs into the function f, and t is just the input, in this case apples. Another way of looking at it is two machines, and as soon as you input something into a machine and it puts out something, it drops the output of the green machine into the F machine, and the resulting answer is something that is resulting of putting the output of the G machine into the F machine, and you get what's called a composed function. Okay? And here's another visual to help you get an example. So in order to be able to define a composition of two functions, their domain and their ranges have to have enough value so that you can be able to always put in a value x that will produce an output. So sometimes the domain of G needs to be restricted so that you can guarantee that the range of G is completely within the domain of F, so that we can make sure we can submit things in G and make sure we'll be able to get things out of F. So let's take a look at another way of composing it. In this case, we inputted everything into G and took the output of G and put it into F. But what if it's the other way around? And the other way around was we put an input into F and take the output of F and put it into G. And that's a G composed F composition. So up here, it was F composed G, and here is G composed F. And there are two ways to describe composition of functions: using this format and using the symbol. It looks like an O, but it really is a small circle, which represents composed, G composed F. Okay. So you're going to be asked to be able to determine values of a composite functions. A variety of different ways. The simplest way is the equation way, using the functions. So if I want to do G compose F, then I'm going to take whatever F is and replace the input of G with what F is. And then I'm going to use that input. The input of G is 2x plus 1. Well, what does G do? It takes its input and divides it and and he takes 5 and divides it by the input. So we're going to take 5 and divide it by the input. So this expression here represents the function of G composed F. Let's look at F composed G. We're going to take as its input X and put it into F instead of G. When we put it into F, well, what does the output of G do? Output of G is 5 over X. When we put this into the input of F, you're going to multiply the input of F times 2 and add 1. And that's exactly what we did here. We multiplied the input of F times 2 and added 1. And this is the result of f compose g. If I want to input a particular number value, so I input 5 into f, and then I take that result out and put it into g, this is what I get. Very simple. Let's move on to the next one. What if I want to do that composed of tables? Well, if I want to figure out what is g when I put in 2, well, when I put in 2, I don't know yet because I don't know what produced that. So first I need to figure out what g compose f of x is when x is equal to 2. When I put into 2, I get out 1 for f of x. So the question is, which input, when I put it into g, will give me an output of 1? Well, that is also, here is where the output of g is 1. And what caused this input? 1. So therefore we have g compose f of 2 is 1. Okay? Using that same rationale, if I want to figure out what do I need to put into g to get out 1, well, if I look over here, I get 1. So the question is, what do I need to put into f to get out 1? And that's how we end up with 2, because when I put 2 into f, I get out 1. And when I put in 1 into g, I get out 1. And that was my answer for this. Okay? How do we decompose functions? Decompose functions basically means to determine which f and g produces the composite function. F compose g of x. So there are many different, there's not just one way you can do it, but here is an example. If I let f of x be equal to 3 times the square root of x, then g would have to be what was inside the square root, which is x to the cubed power minus 4x. That's one way. Over here, 1 over 2x minus 3 to the third power. Let f of x be equal to 1 over x cubed. Well, that means g of x would have to be what's inside that x cubed, which would be 2x minus 3. And the same in this case. Here's an example of an answer, and here's an example of the answer for this one. All right, that's it. Hope you enjoy. Work on the practice problems.